Let's go ahead and get rolling here. Hopefully you guys can all see my screen. Rob, you're coming through a little bit on my mic. I don't know if that... All right. All right, everybody. So today I have the pleasure of presenting to the PASS PowerShell virtual chapter. My name's Drew, and I'm going to be talking about multi-threading in PowerShell today with Runspaces. A little bit about me before we get going. So I think some of you may have seen me present before. I had a session last Friday on GroupBy, and I know I presented SQL Saturday about things, but I'll be fully upfront with you. This is kind of the first purely PowerShell talk I think I've ever given, and as such, it's slightly a different topic for me, breaking out a little bit, exploring, and doing some different things. So bear with me if I say something wrong. I'll try not to get too much wrong because I know Chrissy and Rob and Aaron will yell at me, but I'll try to keep it going here. So a little bit about me, senior DBA at a company called IGS in Dublin, Ohio. If you live in the US and you're a customer, that's great. I would love to hear from you. I've been using SQL Server since about SQL Server 2000, back in 2002, so it's been about almost 15 years that I've been working with the product. And my day job is most definitely a DBA. But here at IGS, we wear a lot of different hats, and it's funny because before I came to IGS, I was aware of PowerShell. I had dabbled a little bit, but it really took me starting here to embrace just how powerful PowerShell really is. For example, here at IGS, we do so many different things with PowerShell. We do our code deployments and our application deployments. We do database deployments with PowerShell. We administer so many different things, whether it be AD, Exchange, even a little bit of SharePoint administration through PowerShell. And when I came in here, I was really behind the curve. We weren't necessarily as a company using PowerShell to do anything with SQL Server other than deployments, but since then I've really embraced it, and I've taken time to learn the scripting language quite a bit and learn a lot how to do a lot of different things. And today we do things like manage backups, and we do some pretty complex code deployments now with PowerShell, so we're deploying things like SSRS and SSIS with it. So a lot of different things that I've had to learn that have helped me improve as a DBA in learning PowerShell. And I think, since I'm going to assume, maybe incorrectly, that this is the PASS PowerShell VC. I'm going to assume a lot of you are also DBAs on the line, or maybe you are PowerShell people and you want to learn about multi-threading. I will say that most of this talk is mostly about multi-threading in PowerShell, but at the end I do have an example of a recent project that I completed where threading really kind of saved my life, so to speak. So in addition to being a DBA, I do a lot of DevOps, a lot of release management, a lot of PowerShell writing. So contact info here. It's always really funny to listen to people say my last name because it's a burden. My email address is right there if you want to reach out to me. The other way you can reach out to me is on Twitter. I'd love a follow. I'd love a, hey, you're great, or hey, you suck. Any kind of feedback's good. My website is port1433.com, and the reason that I call that out is a lot of times when I blog, I'm doing it here. But the link I want to call your attention to on my website is this link to GitHub, and I think it'll probably crash my wireless if I try to do it. But if you click on that link, you'll go to my repository on GitHub, and a lot of the code snippets I write and the things you're going to see today will be on my GitHub either shortly after or at the latest tomorrow morning. I'll make sure all the code snippets and examples are out there for you to download, so make sure you click on that. The other website I want to call your attention to, and I just do this at the beginning of all my presentations, is this website called genesface.com. It's pictures of my boss, and he's an incredibly good sport. It was something that existed before I started at IGS, but I've really taken a liking to it, and I know there's people on the line here at IGS that have seen it and know Gene very well. He's kind of in a banana phase here. I don't quite get it, but he's a pretty good-looking guy, and in all seriousness, I know we like to show this, but Gene's a great boss, and he's part of the reason that I'm empowered to do the things that I do. So just like to show that off. So anyway, contact info, all that stuff. If you're interested, that slide will be up at the end, and feel free to reach out to me. I would love to hear from you. All right, so today I'm going to talk about multi-threading in PowerShell. I'm going to talk about why that's kind of a good thing to learn. It's incredibly powerful. It can be a little complex and even a little scary if you've never done it. So pretty much the first part is going to be talking about why, and then I'm just going to show you how. So I will pull up a couple examples. I'll walk you through kind of how to create a run space in PowerShell, and then how to kick them off and how to monitor them, how to figure out when things. That was weird. I got muted there.
Everybody's muted. Now, as strange as that you weren't muted. You keep going.
It said I was muted. That was weird. Sorry, guys. What was the last thing you heard there? Yeah. Oh well, I'll just keep going. Not sure what happened. So I'll
I'm
talk
so
about how it
sorry,
works.
Drew. We are having mic issues over here, and we're trying to get them resolved, so I totally apologize for that. We are trying to resolve it, and you shouldn't hear it.
Oh, no worries. No worries. The other thing I want to talk about is if you've done parallelism in PowerShell without using Runspaces, chances are you've used the *job command that's like invoke job or receive job. So I want to show you why, if you're using invoke job, why you may want to look at Runspaces for future development and using PowerShell. I'll have a really good demo of that. And then the last thing I want to talk about is kind of a very in-depth example of something that I completed here that is actually going to production here at IGS that I finished that is going to help us with some code deployments. So that's pretty much what we're going to do. So multi-threading, right? What does that mean? Well, if you write a PowerShell script, chances are it executes serially. Okay, I mean, you can declare things like functions, and you can write scripts that go out and pull things back from computers. Maybe you want to get free space in a database, or you want to figure out what processes are running. Okay, I mean, that all executes serially, and whether you do it one at a time or you pass in a collection to a function and or a commandlet, it'll iterate over those things and it'll return the result back to you. And a lot of times that's completely fine. There's no reason to start saying, well, I need to multi-thread everything, because if it returns relatively quick and you can optimize the code, then it probably is fine for what you're trying to do. But it all becomes a question of scale. So if you have something that you're trying to do on maybe 40 or 50 or 100 servers, that commandlet or that function that you wrote may not necessarily run very fast, and that's not a function of your code. It's just you have to go out and get a lot of things. So whenever you get to that kind of n+1 scenario, multi-threading is a great way to speed up your scripts. So, one of the examples I like to say is if I have something that takes maybe 5 seconds to run, a commandlet to go out and get something from a database to query a table or something, and I need to do that on 20 servers, that's, what, 100 seconds-ish? I don't know. I'm really bad at math, but it's a long time. So you want to multi-thread that stuff out. Try to bring it back a little bit faster. Now, there's a lot of ways to do that, but Runspaces are kind of the quote-unquote hotness, if you will. So Runspaces are great because it is true multi-threading. When you spin up a Runspace, you're basically taking your PowerShell.exe process and you're spinning up an existing thread on that process. You're not actually spawning additional PowerShell.exe host. You're just spinning up a thread on an existing PowerShell.exe. What's the word I'm looking for? Process. Sorry. And the threads can be sent off asynchronously. So if you want to send a command off to 20 servers, you can do that, and it'll all complete whenever they complete. Maybe one server's faster than the other, so you get that result back even though you spun up that particular thread later on in your process. And Runspaces are really cool too because there's kind of safeguards and things in place to make sure that your threads don't necessarily get out of control. In the examples we'll see, you basically set a lower and an upper threshold to say never spin up more than X number of threads. So even if you are queuing up 100 things, you won't necessarily crush a server or crush a workstation with 100 things running at a time. So that's one really, really good thing about that. And Runspaces can be thought of as like a really, really advanced function. It can go and run code and it can return things. You don't necessarily need to fire and forget. One analogy that I've kind of related to people to in the past is you can kind of think of Runspaces as a SQL agent job. Maybe you have T-SQL code living in a SQL agent job and you can right-click Start Job and it goes off and runs, and it doesn't necessarily return results, right? You can have that log to the console in a SQL agent log, but it's not like you get the results back from the SQL agent to say, hey, you returned 1,000 rows or something like that. Runspaces, you can get that. You can pull back the results of whatever you ran. You don't necessarily need to fire and forget. So that's a really cool thing about them as well. But there are some things that aren't necessarily great about Runspaces, but things you need to be careful of when you're using them. Like I said, if you've never used Runspaces before, you've never done multi-threading in any language, let alone PowerShell, it can be a little daunting. The quote I like to relate is, if you've ever seen Back to the Future, Doc likes to say you're not thinking fourth dimensionally. And when you start to think about Runspaces, that's something you need to consider. You need to think about Runspaces as another dimension, like an XYZ type of thing, or whatever the AA, whatever the next letter is after that, whatever dimension you want to define. You have all these things kind of off and running in the background, and you need to be cognizant of what they're doing and making sure you're pulling them back. So that's why you need to have things like monitoring. Run spaces don't necessarily get cleaned up on their own either. They'll stay there until you get rid of them. So there's not kind of any automatic garbage collection or anything that goes on with that stuff either. And run spaces can be hard to troubleshoot. So if you send bad code off into a run space, you don't get that awesome red text saying, hey, you got an error at this line. You can still get that information, and I'll show you how, but it's not readily apparent about where it is, or even if you had an error. And then you run into issues of scope, like modules and variables and anything else you define in your main thread process don't carry over to your run spaces either. So these are things you need to be aware of if you start writing code or taking existing code and threading it. You need to design it in such a way that these things can be compartmentalized and still be used all throughout. The other movie quote I like to relate in this thing is, you were so preoccupied with whether or not you could that you didn't stop to think if you should. I don't want people leaving this session today thinking, I'm going to multi-thread all the things, because that's not great. That's not what you should be trying to do. This isn't what this is about. And this isn't a hammer in search of a nail, as I like to say. You don't necessarily need to go around and start optimizing all of your scripts to be multi-threaded. If a script is slow, multi-threading necessarily won't fix it. Bad code or not great optimized code is just that. You could probably take it and optimize it, make it better. And then when you start looking at problems of scale is when I would say that multi-threading can come to your rescue. And like I said in the previous slide, is that if you have something that doesn't necessarily work right, then you can really screw things up pretty quick. One of the favorite quotes I heard about PowerShell, and I don't know who to attribute to, so if it's you, that's great, but PowerShell is great if you want to fail at scale. So if you have a bad code or a bad script or a bad commandlet that you go out and run on a bunch of servers, you're going to have a bad day. But if you're using multi-threading and you're doing this on servers that you don't necessarily get that bad feedback for, you're going to have a really bad day. So instead of failing at scale, I like to kind of think of it if you're basically failing at scale to the X power. So if you have scrutiny in the code that you run in production, you probably want to be extra scrutinous of any code you run in a run space. Okay? So that's kind of my elevator pitch about what run spaces are, what they do, and multi-threading. So let's look at some examples about how actually we create run spaces, because I could sit here and I could talk all day about why they're great and why they're good and everything, but actually seeing them in action I think will make it click for a lot of people. So real quick, I'm running a couple VMs here today. So on my machine right now, I've got 5 machines up and running. Having 32 gigs of RAM in a laptop is just amazing, by the way. So I've got a domain controller, and I've got 3 SQL servers, and I've got a Windows 10 machine just because I like using PowerShell 5. So I didn't necessarily want to run this on a 2012 server using an older version of PowerShell. So let's go into my VM, and hopefully you guys can all see that. So what I want to show first is kind of a traditional serial example of something that I would run against a bunch of servers at a time. So what I have is I have an array defined here full of SQL Server names, SQL Server A, B, and C. And I have that duplicated a bunch of times just because I don't want to spin up 20 instances, but I can reuse them and go get it. And then I'm using a stopwatch class, which is so great if you're doing any kind of performance tuning and you want to see how fast your scripts can run. I love using stopwatch for this just because I can tell it to stop and get things like elapsed to figure out how many milliseconds have passed since I've started to do something. Really easy to use. It's just great. So I'm a big fan of stopwatch. So then I'm going to iterate over that computer collection. And what I'm going to do is I'm going to use invoke command, run that command, run basically this script process on each of these remote machines. Perfect. Then each time I run it, I'm going to write to the host how long for it to go out and return the command. So let's go ahead and run this real quick, and let's see what happens, just to get a baseline. Okay, so this is going to iterate through, and at the bottom of the screen here, hopefully we can see that pretty good. ISE is not great for this. There we go. You can see that it's taking on the average anywhere from a second to a half to maybe 2 seconds to run this every time. Is that great or is that bad? Well, I mean, that's completely up to you, right? If that's slow, right, if you're DBA, you're probably familiar with something like cost threshold for parallelism, right? So what does SQL Server do if you have an expensive query? Well, it takes it and it chunks it out and it'll thread it. And if you're a DBA, you probably know the woes of the CX packet wait stat. Well, in our case, we don't necessarily have an internal max degree of parallelism setting or cost threshold for parallel setting. We just know that it feels slow. So this took 20 seconds to get the processes off so many different machines. Can we speed this up with threading? We absolutely can. So let's actually go ahead and create a run space to do the same thing so we can thread this out. So the top of the script looks the same from what I just did. I have a computers collection again, same number of computers, nothing up my sleeve. The first thing you want to do here is to create a run space, you create what's called a run space pool. And this is kind of your throttle framework behind the scenes that determines how many different threads run at a time. You're creating a run space factory with a run space pool, and you basically will pass it two numbers. What's the minimum number of threads I want to run at one time, and how many threads do I want to run at one time? Now this VM only has 4 cores dedicated to it, but that doesn't necessarily mean I'm limited at 4. I can spin up additional threads to do this, but 4 is a nice, decent number. Now a quick note about this. The last thing you should tune, in my opinion anyway, the last thing you probably want to tune when you're working with Runspaces is the number of threads you're spinning up. When you first write this code, get your code working first, and then start playing with that max thread number to see kind of where your sweet spot is, because you will hit like diminishing returns, or at worst case it'll start to get slower because you're overwhelming your computer with threads. In this particular case, I'm just going to use 4 because it runs pretty fast for this demo. So once I declare my run space pool and how many threads I want to run, you need to set the apartment state of the run space pool. The apartment state basically tells the threads if they should run synchronously or not. Okay, there's I think 4 different settings according to MDM. There's like unknown and none and MTA and STA, I think. I don't know why you wouldn't ever set this to MTA unless you were worried about what order your threads completed in. Okay, got another weird GoToMeeting thing there. Sorry, guys, or webinar thing. But anyway, you set the apartment state, and it will basically show you, or it'll basically determine if it runs multi-threaded or not. So MTA means it's going to run multi-threaded. Then once you determine that, you run runspace pool open, and the pool's open, right? Get your pool noodles, get your sunblock. The pool's open for business. We're ready to start running threads. Now, in my previous example, I wanted to run a particular command, in this case, invoke command, get process from a computer name. So instead of running that kind of serially, I'm going to declare a script block called code container. And in code container, I'm going to accept a parameter called computer name, and I'm going to capture into a variable called process the same command that I just ran, right? So it's going to go out and it's going to get those processes. Cool. And I'm going to return them when I'm done. So that's all this script block does. Now we're going to use that script block down in the next section. I'm going to create an empty array called threads here. And what these threads are going to do are going to hold different objects that these threads are going to spin up. Again, I'm going to use stopwatch to kind of capture just how fast this runs. And then I'm going to do the same thing that I did before. I'm going to iterate over the list of computers. But instead of kicking off the invoke SQL command this time, I'm going to declare a run space and tell it to go off and run. So the first thing I'm doing is creating a custom object of my own design here called a run space object. Now I have 2 properties inside of here. The first is a property called run space. And that run space actually holds the run space of the thread I'm going to spin up. That's what this command does right here. I'm also declaring another property called invoker. Now we're going to use this later on to store the status of the thread. Okay? It's kind of inception-y. We're going to create this run space object that runs a run space, and then we're going to tell the run space to run and return the result to a different property inside the object. I know, right? Again, a little goofy, but bear with me. So then for the run space object that we just created, for that run space property, I'm going to say, what pool do you want to run in? Well, I declared a run space pool called run space pool above. We're then going to say the script I want you to run is my code container, and I'm going to use out and all because that returns something if you don't. Then we're going to use add argument. I know it's lazy. I should probably be using add parameter, but I was in a hurry. So I'm just going to do add argument to add the current computer as a parameter to that script. Again, using out and all because that returns something. Now, here's where things get interesting. For the run space object, I'm going to say set the invoker property to be the runspace.beginInvoke method. This method returns an object, like an iasync object, that tells you what the status of the thread is. Did it complete or not? So when we're trying to figure out if something completes, we're basically going to be looking at the invoker property of our run space object. And to get results out of the run space, or to see what the run space actually returned, we're going to be using the run space property of our object. So then I'm going to add that custom object to my threads. I'm basically going to capture how long it took to spin up the particular thread in question. I'm going to capture how long it took to do all of the to spin up all the run spaces. And then I kind of hit this line here. So this line right here is kind of like a conductor or a signal on your railroad tracks. What this is an empty loop. I don't want my script to continue until all the threads are done. So what I want to make sure is, did all the threads complete? Now remember that the invoker property of our object holds whether it's completed or not. So I'm looking at an entire collection to make sure that none of them contain false. If that's the case, that means they've all finished, good or bad, and then I can move on to the next part. The next part is where I can pull back my results. Again, I'm using a method on endInvoke, and I'm using the async object of invoker to pull back to make sure that it's done, and then pull the results down and store them in the variable called thread results. And at the end, you can see here that after I'm done with each thread, I'm calling the Dispose method on the Runspace, and that'll make sure that I'm actually tearing down the threads when I'm done with them. And then finally, I close my Runspace pool. Pool's closed, get out, mandatory 15-minute break. You'll cramp up if you don't stop. Okay? So if you've not written a lot of PowerShell, that might seem a little bit confusing, or if you're new to multithreading, that might seem a little weird. But the question I think everybody's asking is just how much faster is this? Well, let's find out. So there we go. It took me about 1/10 of a second to spin up all my Runspaces and 5 seconds to return them all. Compared to, what did we say? I forget how many seconds it took last time, but it's a pretty considerable improvement. And did it actually return everything? Good question. It sure did. So there's a bread and butter perfect example of how multi-threading can speed up your scripts. Okay, I think the other one took like 30-some seconds or something. I totally forget. I wasn't paying attention. But anyway, that's a perfect example of how you can do Runspaces to multi-thread something. Now, that's great, okay? But what happens if multi-threading goes wrong? Because, I mean, I could show you a bunch of different examples about how to spin up Runspaces, but that's pretty much the big example there. So let's talk for a minute about what happens if Runspaces don't work. How do we get things back to figure out if something goes wrong? So let's take the same code we just did, all right? But this time, we're purposely going to break it. So literally same exact code, less computers, just because I don't care so much about speed or how many objects I'm going to return this time. But I do care about breaking it. So this time I have a super obvious error in my code container here. And in my code container, I have a commandlet, get process, and I just added a bunch of X's to it. Clearly, that is not a commandlet that exists. So I'm going to purposely pass my Runspace bad code. Well, what happens? Let's run this again. Okay? The Runspace is created really fast, and they finished really fast, but if I look at thread results, it's empty. It didn't get anything, so clearly something didn't work. But how do we figure out what broke? I mean, we as humans know, well, Drew, you passed it a bad commandlet, but if you have particularly complex script code in there, that can be a little hard to figure out. So what do? Well, this time, instead of letting the script finish all the way, I'm not going to tear down my threads. So I'm just going to run it to here. Okay? So now let's explore the threads object, because we really didn't get to do that last time. So here are my threads. I have 3 computers, so it spun up 3 different Runspaces, 3 different threads, if you will, to capture this information. And here are my 2 objects that are each part of the threads collection holds a Runspace and an invoker property. Well, what's in those things? Well, we already kind of know what's in invoker, right? So if I look at this, I can see what the status of every thread is, which is why we monitor with that loop. I can see is completed, what's the async state, the handle, all those other things. All we really care about here, though, is completed. So it is saying all the threads finished, but they didn't finish correctly. Well, how do we get error information out of a Runspace? Well, the other part of this object is threads.runspace. And in here, for every thread that we spun up, we have some more properties to look at. Had errors. Okay, cool. But what is the error? Well, these threads use streams to communicate back to your main process. So if I look at runspace.streams, each thread has a different stream that it can return information back on. And in this particular case, I can see that there is an error stream here of command not found exception. So if I do something like this, if I take the very first thread and then I click streams, not click, but type, I don't click, this is a shell, error, I can actually get the exception from every thread, okay? So every time you do something like a write error or a write warning or a write host or write verbose, write info, those will go to those different streams inside each of your threads. And if you have an error, you'll want to check the Runspace object, whatever you're using to actually create the Runspace. If you're using my template, it would be .runspace in the object, to actually see that there's an error. Okay? Some of these will finish with errors, some of them won't. So that's how you pull that information out. A lot of times, and you know, if you have multiple errors, you can do things like this. Just like you would if it was your main console, I could say error 0. Right? I can do things, it's just like your work, once you start using the stream, it starts working like any other error object that you would work with inside of PowerShell. Okay? Same thing goes for verbose or any other stream you pull back, but if you want to get into things like inner exception or things like that, you know, those become things you can start working with the streams. Okay? So understanding how to look and see if your threads are returning anything or if they have errors, that's how you're going to do that. You're going to use the Runspace object of that custom object that we created to pull that stuff back. All right. The next thing I want to talk about is kind of scope inside of these Runspaces. I made mention of it before and how scope can be a problem. Let's look at an example of that. So the first thing I want to do here in this example is I want to create a PS drive, and I want to call it temp drive, and I want it to point the C temp drive of my local machine. So I run that, and you can see that it went and it got child item out of everything in my temp drive, and clearly there's things there. And I can go to my temp drive, and lo and behold, it's just like browsing my C temp folder on my computer. Okay, we obviously know the drive exists within this context. So let's say I wanted to spin up a Runspace against my local machine here to go out and get temp drive. I'm just going to make this a single thread just to show you an example. Let's go ahead and see what happens. And I'm just going to run it down to here so we can look at our threads. Cool, it finished, but did it return anything? Well, if I look at my threads.runspace, it had an error. And if I look at the error, streams, drew, error, a drive with temp drive doesn't exist. I mean, I created the temp drive, I can hit it from this instance, but it didn't carry over into my Runspace, okay? Remember, it's basically spinning up a new thread, which I guess technically is a PS host, but anything that it knows about in this particular process will not carry over. So you're probably thinking to yourself, well, what about modules, Drew? Because if you know me, I love the SQL Server PowerShell module. I use it for almost everything. I give my talks and I say how awesome it is, right? So if I want to start multi-threading with PowerShell, now we're going to start bringing this back to the database side of the house. We can see what happens. So I'm going to import this module. Now, what's one of the first things that importing the SQL Server PowerShell module does? If you use this as much as I do, you'll know that it basically creates another drive called SQL Server that we can then use to get path information from and pull back objects with. Super fast today. So just to make sure that it's actually loaded. Okay, cool. Obviously, I loaded the module and it's there. We all see it, right? I'm not streaming. It's early, but we can clearly see that it's there. Will that be visible in our Runspace if I load all those modules and assemblies and all those things? Okay, I ran it. And what I'm doing is I'm going to get the path off of SQL Server A to get my databases. Ran really fast. It's probably not a good sign. Let's look at the error stream. Okay, I can't find a drive with SQL Server. So important information here. If you write scripts that rely on modules, you need to make sure you load them in each of your threads. That can be slow. You may actually lose some of the benefit of multi-threading if you do that. So that's an important kind of design or architecture thing to think about with threading is, what do I do if I need modules? Okay, those don't automatically come in. Now, if you're very clever, you're probably thinking to yourself, Drew, I know what I can do. I can create a profile, and that profile will have all the modules I need, and then every time I spin up a PS host or PS thread or PS command, hey, I'm going to get those things. Well, let's talk about profiles for a minute. So I already have a profile created. Let me just show you what it looks like here. Oh, where's my mod? Okay. So here's my PowerShell module. What does it do? It's going to go out to my temp drive, and it's basically going to do the Linux or Unix equivalent of a touch. It's going to create an empty file with a timestamp of every time I run PowerShell. So if I go to my temp directory real quick, let me get rid of this clutter. Should have done that ahead of time. So we can see in here that I've clearly started PowerShell a couple times in the last few days. So if I run this, cool, obviously my profile's working, right? You all see it, it does it. And it created a new file with this timestamp of, hey, PowerShell start. Pretty cool. It's empty, but it's basically just writing a file. I'm using that as proof that, you know, my profile is there and actually working. So what happens then when I spin up Runspaces? Will it use my profile? Will it blend? So I'm going to go in here and run the same thing again. And what I'm doing is in my profile, I'm creating that temp drive. So if it truly does use my profile, I should be able to pull back temp drive, right? What happened? Temp drive doesn't exist. So when these threads create and spin up, it does not load a profile. Okay, it's either designed not to run a profile, or it's running under a different kind of process ID that doesn't know about your profile. I don't really know the answer. I couldn't find an answer. And if anybody knows, Rob, Chrissy, Aaron, if you do know, would love to hear what the case for that is. Yeah, so that's kind of how that works. So profiles, things like that, if you wanted to try to defeat that scope with profiles, not going to work. All right, so there's some solid examples of how you can do Runspaces, how to spin them up. I kind of gave you the bone stock example. I'll have a link to where I stole that from. I think someone on the call already knows, but where I kind of stole that example from, and what you can do to start using it. And I wanted to communicate to you how to troubleshoot them, because really what I found is that once you kind of grok how to spin up these Runspaces, the bigger question then becomes is how do you troubleshoot them or use them effectively. So I really wanted to carve out the time that I did to show you those error streams and how to figure out if your threads did have an error. So mission accomplished there. So the next thing I want to talk about before we move on is I want to just briefly mention start job and receive job, because I think some people who do multi-threading today rely on start job and receive job, and that's totally fine. I'm never going to say what you do is wrong just because I don't want to be that guy. I don't want to say do it my way or don't do it at all, because I don't like that. I chafe when people say it to me, and I don't want to be a hypocrite. So if you're using start job and receive job today, in no means am I saying you should rewrite everything to use Runspaces. But it's important to understand the differences and why there can be an issue. So what is the difference? Well, with start job and receive job, with Runspaces, every time you spin up a Runspace, you're spinning up a thread on an existing process. With start job and receive job, you spin up additional processes of PowerShell. So if you were to kick off 100 start jobs and have them all run in the background, you essentially have 100 processes of PowerShell running. I don't want to do that because it'll crash my computer and then I'll get disconnected and you guys will wonder what the hell happened. But start job spins up additional processes. It doesn't spin up additional threads. And there isn't the built-in throttling that occurs with Runspaces as there is with start job. There is a throttle parameter. I wasn't completely clear on what it does, but I can tell you what it doesn't do, and it doesn't stop it from spinning up too many instances at once. That's kind of left to you to say, you know, spin up 5, wait for those to get done, spin up 5 more, wait for those to get done. You know, that's on you with start job and receive job. The question is, though, is that what does the difference look like between start job and receive job? Well, I'm glad you asked. So I have a start job example here. Now, my first example is what we've already seen. Go out to a computer, run get process, and return everything. So let's go ahead and run that and see how long it takes so we can compare. And I will tear them down all this time. So 1/10 of a second to create all the Runspaces, and then I think it took like, yeah, about 5.5 seconds-ish, 999 repeating, to return all those things. So now let's do a start job example. So very, very similar code. I have a list of computers. I have something that's going to hold all my jobs, and a counter just for naming purposes. So instead of spinning up run spaces for each of my computers, I kick off start job, I'm passing it a code container block, and I'm giving it a name, an argument list. I'm going to do verbose so we can see what happens. I'm going to use elapsed to capture how long it takes to spin up every job. So far, not too dissimilar from what we've done with run spaces. Now, again, we're going to monitor every job to make sure that we don't move ahead until all the jobs finish, to be fair. Then when I'm done, I'm going to iterate over every job, and I'm going to use receive job to basically pull back all the output from that particular process and capture the information in a variable called job results that we can then look at. So we saw that it took 5 seconds to do it with run spaces. What about start job? Da, 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 da. So hopefully while you guys are waiting, you're getting the chance to answer questions. Oh, look, there it goes. It took 12 seconds to spin up the very first job. That's interesting. It took 14 seconds to spin up all those jobs. Okay, that's not so bad. So now it's waiting for them all to finish. Again, starting up processes, loading up profiles, da-da-da-da-da. Again, remember I did have a profile defined, so that gets taken into account. So it took 34 seconds to do the same amount of work with a job. Okay? And again, a lot of that difference can be accounted for how it spins up additional processes instead of threads, and the fact that it has to contend things with like importing modules as part of your profile, or you know, spinning up drives or anything like that. There's a lot of additional overhead that goes into something like this. So if you have something that's running parallel today, maybe it was running in 30 minutes before you use start job and receive job, and you got it down to 5 minutes. You may, I say may because your mileage may vary, you may be able to get that a little bit faster if you consider going to run spaces. And oh, by the way, you have that built-in throttling to say only do 4 at a time. So I just want to show that. I mean, by no means saying take all your code and blow it up because it's terrible and it's wrong. It's just something to consider because I'm a big fan of run spaces. So I have to do that. I have to say that. Okay. So quick time check here. So I've got about 20 minutes left. So what I'd like to do now is I'd like to bring all this back. Okay, so I've talked about run spaces, how to troubleshoot them, how they work, all that. I want to talk about a real-life anecdotal experience about how a run space helped me, or a run space management process helped me. Okay, and I'm doing that. I'm framing this in a discussion of master data management. So master data management can mean a lot of things to a lot of different people. Here's what it means to me. It means that I have a series of control tables somewhere, whether it's a list of salespeople IDs or zip codes or holidays. I have some piece of data that I need to share multiple places with multiple systems, but I only want to administer it one place. Now, there's a lot of different ways to manage something like that. Microsoft has, you know, master data management products. There are other third-party tools that do the same thing. Maybe you're relying on a process like replication to push these things out to multiple servers. Or maybe you just have a bunch of link servers set up. However you're doing it today, I'm sure it works for you and it works totally fine. Here, though, we wanted to make sure that our kind of master data tables, if you were, all live within the systems that consume them. So that means that when we release an update to master data management, not only do we need to have code checked in that handles changing the data or changing the objects, we need to make sure that those objects get persisted out to our various production systems that need them. So what did we do to handle that? Well, since we're a pretty PowerShell heavy place, I wrote a script called copy database tables, and if you've seen me present, you may have seen me use this script before. What this does is it takes a bunch of parameters, and essentially, and I'll kind of walk you through it here as we go through. What it does is it points to a kind of a master repository of data. Now, in our particular instance, I have a schema defined on my master data management database that contains all the tables that we want to copy. And then that schema is persisted on all of our replicas, or not replicas, the wrong word, all of our production systems that need the data. So in this particular instance, in this example, I'm going to be using the sales schema out of AdventureWork. Let's say for whatever reason, that sales schema is our master data model that we need published to our locations. So this script takes a source system, if you will, and a destination database, and it copies everything out. But it's a little more complex than that because the way this script is designed is we want to make sure we have the most up-to-date information from the master data. So what we do is we go out to the source, we not only copy the data, but we want to make sure we capture the structure of the table. So that means that every time we do this deployment, we need to drop and recreate these objects at the destination. Now that can be tricky. If you've ever worked with replication, that can be a big bugaboo in that if you drop an object, you have to worry about if there's dependencies on that object, and because it's master data, there probably is. There are probably things like foreign keys or indexes or explicit permissions defined on these objects that if you drop and recreate them, you're going to lose. So we need to make sure we capture that stuff ahead of time and then reapply it after we recreate the objects. And that's what this script does, is it iterates over things like schema-bound views and permissions and indexes and foreign keys, both on the tables that we're dropping and any tables that references the tables that we're dropping, scripts them all out and puts them back. Now there's a problem with this script, and it started to haunt us a little bit in that we can only do this one at a time. So for every system that needs this, we're basically spawning a new process and copying this out, which means I need to read from the same server X number of times and then apply it X number of times. Now if that were necessarily a fast process, I may not care. But in this particular case, sometimes it's not. So let's go ahead and run an example of this so we can see just how fast it's kind of running. That's on my desktop. Come on. I can type today. There we go. So I'm going to do copy database tables, and I have some parameters that I pass this. So my source server in this particular case is SQL Server A. Never type in demos, they say. I just forgot to copy paste ahead of time, so we're just going to do this. Source database name is AdventureWorks 2014. My source schema name is sales. If I wanted to limit it to a table, I could, but I'm not. Destination server name is, we'll say, oh, let's take it to SQL Server B. Destination database names is target DBB1, I believe. Let me make sure. So on my servers, I basically have two target databases I'm going to be copying to. In my examples, yeah, so target DBB1. Let's just use that. Destination schema name, let's keep it simple. We'll put it in the same schema as sales. Then I have this parameter called working directory. Well, why do I have that? Well, if this thing dies halfway through, I'd be SOL if I wasn't kind of saving my existing objects or existing indexes or existing foreign keys in case there's an error encounters halfway along the process. So I have a little ripcord that it'll write out everything I'm scripting to a file before it does anything else. So we'll say ctemp for this. And then I have a parameter called no check constraints. So like if I were copying this to an empty database, when it reapplies the foreign keys, it basically can control whether it does it with a check or no check. That's a scripting option you can set in SMO automation. So I'll just leave it there out of habit. And we'll say verbose. So let's let this run and see what happens. So this is going to go out. The first thing it does is it goes out to SQL Server B and it tries to find the existing objects that it needs to script out. So it found some schema-bound views, and now it's going to script out from the source these tables that it knows it needs to copy. And we can see here that it took about 13 seconds. Now it's going through and finding foreign keys, unique indexes, anything that it needs to keep, and then it's going to script out all the indexes and unique. Now it's on the foreign keys. It's scripting them out, saving them to a file, and then dropping them so we can drop these objects without getting an error. So far, so good, working as intended. But you can already see that this is not necessarily a fast process because it has to iterate over so many things. I'm going to let this finish. I've got almost 1250. This is perfect. It's almost done, I promise. Man, there's a lot of foreign keys in AdventureWorks. That's why I love using this as an example, just because they foreign key it to the hilt. Cool, it's done. So now that it's done, it's recreated all the tables on the destination, and now it's copying the data over with bulk insert. So it's gone to every table, it's copying all the data. Awesome. Sales order detail is kind of a big table. I'm kind of parched. Still copying. But you can see that this is not necessarily a fast process. Now, in our environment in production, this master data might have to live on like 20 servers. So this process needs to run every time for every place we need to copy it. And when we were only copying this master data to like 1 or 2 places, that wasn't a big deal. But all of a sudden our deployment's taking a heck of a lot longer because I need to copy it so many places. Now, I did all I could to optimize the code, but it can only run so fast. So there you see, it took 2 minutes, 2 whole minutes to do one server. Now, if you're like I said, if you're doing this for 10 servers or 10 databases, that's 20 minutes every time I need to deploy this. That's unacceptable. In an agile, fast-paced environment like this, we can't let something this simple, again, air quotes for those of you not watching the webcam, to be that slow. So, how do we use Runspaces to make this faster? My first thought when I was approaching this was, well, okay, I'll just take all my code, I'll wrap it in a Runspace, and then wrap it in a script block and then spin up a bunch of threads and pass it parameters. Well, that doesn't necessarily work for a lot of reasons. One, the persistence issue, right? That means I need to load the module inside of every time I call that script block. Okay, not so bad. We can maybe deal with that, but it's not as simple as just taking existing code and putting it into a script block. So it was kind of a double whammy of refactoring and using Runspaces to solve the problem. The solution to this then was a couple things. Number one, instead of every time I deploy this, instead of reading from the source every time I need to copy it, let's read from the source one time. That's a pretty big improvement right there. But then once I have it read from the source, I can pass in custom objects to my Runspace pool that contains the script code of the objects that I'm working with and the data already to then just go to the target servers that I want to deploy this to and copy it all out and clean everything up. Okay? Now, the other thing, and if you use the provider, I found some very, very interesting things that are probably going to be a blog post at some point, but if you're using the provider, and I have to eat my own words because I'm always telling people, use the provider, don't create objects. Well, this really bit me in the butt because the PowerShell provider and the PS drive it creates doesn't play very well with Runspaces. You can't necessarily spin up 2 data reader instances using the same PS drive, even if they're in different threads. It freaks out. So basically what you have to do is basically create your own server objects every time using smo.server. And the key to making this work, I'm just going to tell you right now, multiple active result sets in the connection context of the server. For whatever reason, you don't set this, you're going to have a bad time. If you're copying the same database, if you're trying to copy to more than one database on the same server, you need this because for whatever reason, using SMO without this and trying to copy to the same server in multiple threads is pretty much no bueno. So something to keep in mind. I learned that very much the hard way over the last few days when I was preparing for this demo and preparing to finish this project, is that is something that you need. So the question is all that worth it? Did it actually help me solve my problem? Well, let's go ahead and run all this. Now, I am cheating a little bit here just because the way I've refactored this, these parameters really don't make sense anymore. So what I'm going to do for the purposes of this demo is I have some values hard-coded in here. So my source server is going to be SQL Server A. And then I'm going to copy that same data to SQL Server B and C twice to different databases, 2 different databases on the same server. Okay? Everything else kind of stays the same. So we said that it took 1:53 to do one. What do you think it'll take to do all of these? Now, I will say that if I were going to make this a pure apples to apples, I would probably, refresh the databases and empty the cache because the cache is a little warmer now. But the point is that I don't have to read from it every time. So let's go ahead and run this. And I want to stop here because I want to capture my thread output. So if everything works correctly, let's see how long it takes. So while this is kind of finishing up, guys, I'm kind of at the end of my time and I only have like 1 or 2 more slides that I want to show you. So definitely start queuing your questions up if you haven't already. Hopefully this has been pretty informative. So definitely, start getting those questions in. And while this is running, let's go back to my slides just to save a little bit of time because this will take a minute or so to run. So that was something that I solved particularly here for deployments with PowerShell at IGS. And again, your mileage may vary, but if you are doing things like that, threading can be something that really helps you basically be more efficient with your time, which is I think what we all measure things by, especially in the IT world, is fast is usually better. So if you want to learn more about Runspaces while this is all kind of going on, the Hey Scripting Guy blog has a great kind of stairway series, if you will, that talks about moving from start job and receive job and end job to going out and starting to use Runspaces. And then of course Chrissy wrote an excellent blog post at the end of last year that gives you kind of a boilerplate Runspace template. And I definitely would recommend that if you want to just start playing with it today, you could go right to her blog and copy and paste that. If you're not the kind of person that wants to write your own Runspaces, Joe Prox has Posh RS Job on GitHub. It simplifies this a little bit, gives you commandlets to work with. And then these slides, guys, I will tweet this same URL afterwards. If you want to go get my slides, they'll be available on SlideShare, and that's just kind of
unmuted
to go get them. So let's see if that finished. I'm hoping that it did.
Hey, Drew, you meant Boprox, right?
Sorry, yes. I must have typed that wrong. My bad. Thank you, Eric.
No worries.
Okay, so here, guys, take a look at this. 57 seconds to do 4 servers. So I went from a minute to do 1 to just under a minute to do 4. So now, instead of it being a 20-minute deployment, maybe it's only a 2-minute deployment, okay? So like that right there made my boss incredibly happy. It made all my app dev people incredibly happy because now my deployments are going to take a heck of a lot of the time. But did it actually work? Well, if we go out to these databases now and I use Object Explorer, I should see, yep, 12:54 p.m., all these tables were created, right? So clearly it went and did something. And if I look at something like sales order detail, I've got all my keys, I've got all my indexes, it put everything back. Hey, I'm a happy guy. And if I look at the threads here, just to show you, oops, not that. I suck at typing today. So if I look at threads and I look at Runspace, and I look at streams, I can kind of see that I did have some output. So I did do verbose logging in that. If you want to look at this code later, I'll let you discover how I did that because it's not like I can say verbose in a Runspace, right? So how did I do that? I'll leave that for you to discover on your own. But basically all the verbose output goes to the verbose stream. So I have about 5 minutes left, I think, according to my watch. So I'm just going to stop because I've kind of gone pretty fast there, and I hope that I didn't gloss over anything too technical or too hard. So here's my contact info again. Would love to hear from you in any way, shape, or form. So I'm just going to stop and let Aaron and everybody kind of moderate questions here.
Cool. Drew, I'll start with one of the first ones we got. We think we already answered it, but in case you have any more insight to it, looks like Runspaces, the multi-threaded apartment stuff, was not available in the original version of the ISE, but it seems like that's changed. Do you know which version that changed in, by chance?
You know, everything that I read about Runspaces and all the different things, I always see PowerShell 2.0. I've never seen anything definitely changed or added anything later than 2.0, but I don't know the answer to that.
Okay, I'm going to guess that they did quite a bit of adds to the ISE in 3.0, so I'm guessing it was probably then. But
okay.
Let's see, next one, someone was asking about going to out null as opposed to void and the performance difference there.
I can't really speak to it. I don't like typecasting like that, so I just did out null. I don't know. To me, it's six dozen one, half dozen of the other. If there is a performance implication, I'm not aware of it, so I would have learned something today.
Okay, great. Just a bunch of things.
There actually used to be, but it has been fixed in recent versions of PowerShell, or it should have been. I actually haven't tested since I did my own performance session.
And then, Drew, do you want to tell them again where to go to get the scripts that you were demoing today?
So the scripts I will make available on my GitHub. So again, if you just go out to my website and click my GitHub, just because my repository has my last name in it, and I don't wish that on anybody. So go to port1433.com, click on GitHub, you go to my repos. I will name it something like PowerShell VC Runspaces or something like that, and it'll just be a zip file full of examples.
But now we're the VG.
Oh, the VG, my bad.
Yeah, I know, right? They just changed it last week. Just in time. Is it possible to reallocate the max number of threads while the Runspace is processing?
Ooh, if it's open, I don't know. Chrissy, do you know the answer to that? I've never tried to do that. Kind of like dynamically changing how many threads can be spun up? That's a good question. Never
I
thought
haven't
of doing
either.
that.
My assumption would be no. And just for general information, for my max threads, I was working with a guy, he was a C# performance guy at PSConf EU last year, and I was like, I don't know why, but 5 works. You know, for like the minimum was 1, and then 5 was the max. And he's like, oh, it's because it's the number of your processors plus 1. And so now in my own scripts, I just put like env processor count plus 1. I don't know the specifics of why that works, but I know that that was always my sweet spot. And since you had 4 cores as well, I would assume that the same would be true for you.
Could be. Like I said, it's one of those things that I like to play with at the very, very end, just because I don't want to be changing that. I want to get a performance baseline down with some number,
Exactly.
and then figure out, okay, do I need to go more or less? So 5 sounds good to me. I probably could do 5.
I do.
And then Drew, what was the part you were saying
Exactly.
about the profiles for
Yeah, I mean, I would put
Runspaces?
crazy numbers like 50,000.
So one thing I found, guys, is that if you do create a profile, for whatever reason, for however it spins up these threads, it doesn't load profile information again.
Mhm.
So like in the example I gave here is, where was my profile? Yeah, so here's my PowerShell profile where it creates that temp drive. When I then try to, you know, if I were to create that in a standard PowerShell session or even in the ISE, it'll spin those up, but they're not, that temp drive isn't found even though it's part of my profile. So clearly it's not running profile code when it spins up a thread, or else it would have temp drive available to it.
Okay.
That's kind of how I tested that.
Just on the fly troubleshooting, have you tried that, putting that in the current user all hosts profile?
Have not.
Okay. That would be my first guess. I don't know. I'm not the PowerShell guru. That's why we have Chrissy on the line.
Oh, Aaron.
Yeah, I don't know either. We'll see. I mean, that's what we do. We just, you know, try things. That's what I did when I was working with Runspaces. I was like, I don't know what I'm doing. I'll just paste and see what works. And it worked pretty well to understand it and to get a baseline.
Yep.
Yeah.
All right. Well, we are right at the end of the hour. Just wanted to remind people you can go to SQLPSIO/YouTube to see the recording when we get this posted up, and I'll try to get that done later on today.
And guys, Chrissy, Aaron, Rob, everybody that joined, thank you for having me. This is only, I think, the second or third virtual presentation I've done. They're way different to doing the in-person one, so hopefully you guys found this informative. I love feedback, good or bad, guys, so please don't be shy, whether you loved it, hated it, or you want to learn more. Definitely reach out to me. I'd be happy to answer anything I can do for you. So again, guys, thanks for having me.
Thanks for doing this for us, Drew. We appreciate it.
Yep. See you guys.
Thank you so much. Yeah, man, you've been super awesome.
Thanks, guys. Have a good day.
Thank you, Drew.